everyone. Welcome to another session of our Azure study guide. Study series. It's been a very long day for me. So, as you can imagine,
I
but hopefully,
I
we get
warned
more.
you. I warned you before you gave birth to the baby.
Yeah. I know. Yeah,
I
not
told
easy.
you that it's no more rest for you going forward.
Yeah,
So
yeah.
yeah, hashtag no babies over here. So how has it been? How you coping, man?
Yeah, doing quite well. How about you? How's your day?
Man, it's cool. I'm so sad. I know that it may be a bit painful to say, but I've been relaxing. There's been no one crying, no one, no one asking me for food. You know, none of that stuff. It's just been cool.
Yeah, I
Yeah,
know. Well, it's very stressful, but I guess I have no choice. I guess.
yeah.
Yeah,
It's here now, so there's
yeah.
nothing to
But
do.
aside from that, it's a very lovely weather, and I know our audience are excited to join today's session for our virtual networking series. So,
Yes.
David, what do you have in store for us today?
So I'm so excited about this one, not only because we're speaking about networking, but we're speaking about networking with a network guru on the line himself. So everyone that knows me know that I refer to Sir Kofi, as a guru in almost everything. But it's true, right? So Sir Kofi, like you started doing like getting involved in networking like how many years ago now?
Well, I think at the moment probably close about 9 years, or probably getting to 10 years. So
Wow.
it's been quite a long journey.
Yeah.
So yeah, I mean it span off with two companies, so I have a tremendous sort of time with firewalls and networking. So yeah, but I bet you're in the same ship as well. You've obviously master of many trades, and that's one of your area of
well,
expertise as well.
I did networking like many years ago and worked in different network teams and stuff. So but today we're going to be talking about a different type of networking, which is Azure networking. And we'll be looking at Azure networking being a software defined network. So here's
Software
the
network. All right.
exactly, yeah. So it's a software defined network, and we'll see what that means and what's the implication of that.
So it's not like the traditional way of doing things, I believe, based on what you.
Yeah. So that's a very good question, Sir Kofi. So there are some things with Azure networking that's similar and consistent with traditional networking, right? So for anyone that has a background in just networking, there's some things that are consistent, but there are some things that are different. Now, the things that are different can cause a network engineer to scratch their minds because it's. So I'll give you an example, Sir Kofi. When you're working with an Azure Virtual Network, so let's jump
Yeah.
straight into that, right? By the way, here are the objectives for today, but let's jump straight into it. When we're talking about Azure networking, one of the first things to know is that it's a software defined network, right? So this time over here, it's a software defined network. And one of the things, so have a look at this, Kofi. There's no layer two, there's no broadcast, there's no multicast.
So hang on. So what you're saying is that in Azure networking or probably any cloud networking, there isn't any broadcast at all. You don't have to set up any IP address with 255 at the end to take care of the broadcast.
So
So
yeah, that's a very good question because let me go bring up this document. So Azure Virtual Network FAQ document. So I'll bring up this document and let's see what this document says about Azure Virtual Networking. So here's a document, Azure Virtual Network frequently asked question. I'll do a Control F for broadcast. So if you have a look at this, so I do a Control F for broadcast and let's go down a little bit. Says, do virtual networks support multicast or broadcast? And the answer is no. Multicast and broadcast are not supported. Now, to a traditional network engineer, that goes like it's like that's contrary to the things that we learned in CCNA and CCMP and all these other certifications that we've done in the past.
yeah.
There's no broadcast because here's the thing, Sakofi. In a traditional network, if I have my network and I have my subnet, so I have this network, and in this network, I have this subnet. Now, in this subnet, I have two systems. I have system one and system two. If system 1 wants to communicate with system 2 within the same subnet, the way the communication works is that system 1 will send out a broadcast called an HAP, Address Resolution Protocol, right? So you send out an HAP, and the broadcast information will get to system number 2 because it's in the same broadcast domain.
That's
Now,
right.
system number 2 will see that and say, oh, okay, someone is asking for my MAC address, right? I am the owner of this IP address. Someone is asking for my MAC address. And then system number 2 will reply and says, here is my MAC address. And the way it's going to send that information is a broadcast. And it's going to send another half reply. And system 1 will get the half reply, look into that, get the MAC address of system 2, and then through a network switch, the communication would happen. But that's not the way it works in Azure. As a matter of fact, Sir Kofi, if you go to Azure and you do on an Azure virtual machine and you do an app-a, which is a way to get a list of the IP address to MAC addresses, if you do that on an Azure virtual machine, here's the MAC address that you see for all the systems on the same network. The MAC address will be 1, 2, 3, 4, 5, A, B, C, D, E. That will be the MAC address for all of them. Actually,
Wow.
let me show that to you very quickly. So over here in this environment, I have some machines that exist on the same network, right? So I want to show you a few things. So let's go over to web VM01 and let's go connect to it. So there's something that I was very excited about this week, Sakofi. You know what that is?
Yeah, go for it.
So Windows now has SSH clients.
Really?
Yeah, exactly. So
Actually, I use PowerShell. I just spin that up. Sorry, I just load it up and then just SSH directly from there.
from PowerShell. Yeah, but that wasn't the case. Windows didn't used to have SSH client at all.
Okay, yeah,
Yeah, so that's something that came later. So Microsoft now decided, oh, we're going to do the
yeah,
upgrade. So, anyways, that's SSH working directly from PowerShell, like Sarkofi said. And if I go over to connect to my Linux VM, just need to get my password right. Oh no, what did I do wrong? Oh, I can see what I've done wrong, Sarkofi. David. So let's do Azure admin. That's my username, not admin. So let's connect to that. Okay, awesome. So clear the screen. And by the way, I'll make this larger so that people can see the screen. So let's go to make that larger. Let's make that 36. That should be large enough, right? And I'm currently on my virtual machine in Azure. So if I do host name, so webvm01, if I do ping webvm02, right? So I can ping webvm02.
yeah.
So I want you to have a look at something, Sir Kofi. So I'll do app. Let's clear the screen first of all. Let's do app-a. Look at the MAC address of the system. Or look at the MAC address of this. 123456789 ABC.
Yeah,
The MAC address of the gateway. 123456789
yeah.
ABC. Right? So, and no matter how many systems you have on the same network, they're all going to be 123456789 ABC. The reason is that layer 2 doesn't matter in an Azure virtual network.
So everything is layer three.
It's layer 3 and it's unicast. Actually, if we were to look into it in more detail, Sir Kofi, in Azure, there's something called a network controller. And the network controller is the one that's responsible for making the decision on where packet flow. So they don't happen with switches, even though there are switches and routers in the data center and all that stuff. But the
Yeah,
way that communication flow is that there's an abstraction layer. There's something called a network controller that exists, and the network controller will just call that NC. So this is what makes decision about where every packet flows.
that's interesting. So basically, there is no MAC address. So with the devices you spin on the Azure environment or any VNet,
Hmm.
how do they communicate if they don't have any physical address?
Awesome. It's just unicast communication.
Just unicast.
Yes, exactly. So let's move on here. So an Azure Virtual Network is an isolated private network in Azure. It's software-defined networking, which means that there are no layer two, no broadcast, no multicast. Actually, let me show you one more thing, Sir Kofi. Let's look at this document further. We know multicast doesn't work. We know broadcast doesn't work. What else does not work? Have a look at this. What protocols can I use within virtual networks? Says you can use TCP, you can use UDP, you can use ICMP. Unicast is supported, so that's good. With the exception of DHCP Unicast, that's not supported. Um, Multicast, broadcast, IP and IP, GRE, all of those are blocked within the Azure Virtual Network.
So, one interesting thing here is the DACP.
Hmm.
I know with our Azure network, obviously, we do. You can actually set up your address using a static address, but you can also use dynamic. So
Yeah,
when you use dynamic, since you cannot have, there's no DACP, how do they get the address assignment?
that's a good question that we will cover in one of the slides. But
Okay,
to quickly answer that, the Azure platform will automatically assign an IP address based on the subnet that you've put your system.
okay,
So yeah. So, but that DHCP or that automatic assignment is not something that has been put in the control of a customer. A customer cannot set up a DHCP server and have that work in an Azure virtual network.
got it. Right.
Yeah. So another quick one to show you, Sakofi, which is also very interesting. Some people may be happy about this. Let's look at VLAN. What about VLANs? Can I bring my VLANs to Azure using virtual network? It says no. Virtual networks are layer 3 overlays. Azure does not support any layer 2 semantics, which is why all the MAC addresses are 1, 2, 3, 4, 5, 6, 7, 8, 9, ABC.
Oh, I
So
see.
it does not support layer 2 semantics at all. Okay.
So in terms of segregating your network, you have to rely on subnets.
Yes, subnets and something called network security groups, which we're going to cover in a few minutes. Awesome. So let's go on to the next section. So essentially be aware that virtual network in Azure, it's an isolated private network in Azure. It's software defined. There's no layer 2, no broadcast, no multicast, and no VLANs. A virtual network in Azure can also contain infrastructure as a service and platform services. So, because sometimes people may misunderstand when we talk about virtual networks in Azure, people may think, okay, this is talking about virtual machines. No, 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 no. A virtual network in Azure, it's not just about virtual machines. There are other types of services that we can deploy into a virtual network in Azure that are not infrastructure services, they are platform services. For example, if you set up an AKS cluster, well, that's you can consider that to be infrastructure. If you set up something like Azure SQL Managed Instance, if you set up something called App Service Environment, which is a web hosting environment managed by Microsoft, right? App Service Environment, you can set up all these services inside a private virtual network in Azure. So it's not just about virtual machines. Awesome. So that's virtual network. So let's see. So when we create our virtual networks, like what you said earlier, we can break them down into subnets, right? So I can go to break my virtual network down into smaller subnets. And to your point, Sarkofi, that's how we do segmentation. However, because of the software-defined nature of Azure Virtual Networks, we can do segmentation beyond the subnet level. So I'll tell you one funny thing that we can do. So for example, I can have a virtual machine, two virtual machines in the same subnet, Sakofi, and I can configure this to say, before this virtual machine can talk to this virtual machine, I want the traffic to be sent to this firewall over here to do checks before they talk to one another, even though they're on the same subnet. Right? The reason why that's possible is because of software-defined networking. So I can add a root table to say anything that's destination is 10.1.1.0. The next up is over here, even though
Got
they're on
it.
the same subnet.
Got it. So when you have multiple subnet, I mean, by default, can they talk to each other, or you have to define a rule for them to talk to each other?
That's a very good question, Sir Kofi. The answer is by default, yes, they can talk to one another. By default, everything in a virtual network can talk to each other by default. There is nothing restricted on the routing level or on the security level by
Even
default,
when they are in separate subnets.
even when they're in separate subnets. So when we look at NSGs later, if you create a default NSG, one of the rules that exist in a default NSG is a rule that says anything from VNet to VNet is allowed. So in other words, any instances within the same virtual network, even though they're in different subnets, that's
So when
allowed.
you say anything from VNet to VNet, what about, let's say, something from on-prem? Would this match this criteria of VNet to VNet communication?
No. So by VNet that I'm talking about here, so it's not like really like one VNet to another VNet. It's just actually, let me put that in a different way. It's just saying everything within the same virtual network can communicate with each other
Right.
by default. So anything within a VNet, there's a rule in a default network security group that says anything within a VNet can talk to one another. But we'll talk about that in more details in a
Good.
later slide. Yeah. Okay, so let's go forward. So we have a subnet. So a virtual network can be segmented into one or more smaller subnets. The subnet is sort of like the logical division. So, for example, I can create a virtual network. I can break it down to say, here's my web subnet, here's my data subnet, here's my maybe API subnet or whatever, and do all that stuff. And the subnet must have a unique range within the virtual network. And also, there's an interesting thing. The first three IP addresses in each subnet is reserved in Azure. So that's a very interesting point right there, Sakofi.
Right. So when you say it's reserved, so that means you have no power of using those IPs.
You cannot use those IPs.
So in that
Yeah.
case, what is the least number of IPs you can have on a network? So that means you can have slash 32, right?
No, I believe the list is a slash 28, which will allow you to be able to, if I'm correct, I believe I'm correct, but I believe this is a slash 28, which should allow you to have um, essentially a minimum of like about 5 IP addresses. So normally you will have 8 IP addresses to use, but then if you take away the 3 reserved IP addresses, you have like 5 usable IP addresses. And actually, let's go check that out, Sir Kofi. So let's go to the Azure portal. We've been talking for a while. Let's go create a network in Azure. So I'll go over here. I'll go to create a resource. And actually, let me also make my face a bit brighter. So, oh, we've got some questions already, but we'll get to that. So let me go to create a virtual network.
Good question. Okay. Do you want us to look at that first, or?
I can create the network and then we can take the question. No first.
All right. So the question is, when elevating access to manage all Azure subscription, why does the global domain admin grant the domain user a user access administrator not on a role?
So I can see Mohammed is trying to sneak in a question from the last
Yeah.
session. So nice try, Mohammed. Nice try. It's okay. So I'll quickly answer that for Mohammed. So that's fine. So maybe other people have the same question. So the answer to that question by Mohammed. So why does he do that? Because you don't want, when you escalate privilege from Azure AD tenants to Azure subscription, you don't want to get full control because that's too powerful. In many cases, the reason why you're using that is because you've accidentally locked something out. So that's when you use that. So the only thing that you need if you accidentally lock something out is to be able to assign role to yourself. Right. So user access administrator will allow you to be able to assign role to somebody else, and that's what you need at that point. So essentially, it's not something that you use for ongoing management. It's something that, oh, I've locked myself out, temporarily grant myself permission that will allow me to create other permission, create the other permission. Let's go back to the normal way. So that's the reason why. Okay, anyways, let's move on. So that's the answer to Mohammed's question. So let's do VNet research group and let's do instance name. Let's call this UK South VNet 01, and I'll put this virtual network in UK South. And then let's go to IP addresses. So you can see I can specify an IP address range. So let me let me set this to a slash 28. And that allows me, let me set that to a slash 29. and that allows me, so maybe slash 29 is the least that I can do. The slash 30, no. So slash 29 is the
You added
least that we can
29
do.
in front of
Oh,
it.
sorry. Thank you. Yeah, so it won't allow me. So it's actually like, yeah. So
All
this
right.
is slash 29, I think. So, or slash 28, I think. You know what? Let's just go ahead and try that. We're going to know um, whether it's going to allow me or not. So let's try that. Uh, yeah, so you can see here we have 11 plus 5 Azure reserved addresses, and that's what I get with this one. So slash 28. If I put in a slash 29,
Got
so
three.
3 usable, 5 reserved.
That's really good. I mean, at least they tell you what you can get, what address you can actually use
Yep,
in those cases.
exactly. So, but that's a very good question, Takofi, because the least one that we can use is a slash 29.
29.
Yeah. So now with the slash 29, we have 3 IP addresses that we can actually assign. The remaining 5 are reserved.
Yeah. So when you go back to 30, does it, if you type in, yeah, 30, so it says 0. So does it mean you can still create it, but all
No,
the
it won't let you create it.
all
So because it doesn't even have enough to essentially to
yeah.
go to even assign to any resource, so it won't let you create it. So
So
yeah,
now the question is, what are those IP addresses reserved for?
good question. So only one of them is actually reserved for a use case that's defined. So the first IP address in a subnet is reserved for the gateway of that subnet,
Okay. So the net
but the other ones are reserved for future use.
for future
So
use.
Microsoft may decide in the future, oh, we're going to do something with the second IP address or with the third IP address. So they've sort of like kept it for future use.
What about DNS? I mean, when you
Oh,
go,
we'll get to DNS. DNS is massive in Azure.
so that
So
means
let's
your local network, there is no IP reserved for, let's say, DNS. I mean, when you
um
have your own VNet.
oh, DNS is a completely different topic
Oh,
in Azure. So when we get to the DNS topic, you'll see how DNS works in Azure. So Azure DNS, it's a whole different topic in itself. 10.1.0.0/16 and 10.1.0.0/24. Uh, yeah, that's fine. So
all
it's
right.
like,
We got another question here. I mean, let's
yep,
finish what you do, and then I'll put that on the screen.
yeah, let's do that first. So what I'm trying to do here is I'm trying to create a subnet. So I'll create a subnet called web subnet within my virtual network, and I'll give it this IP address range of 10.1.0.0/24. Go ahead and add that. So here we go. So now I have a virtual network. It's going to have that IP address space. Within my virtual network, I have a subnet called subnet. Is going to have that IP address space. And I'll just go ahead and click on create. And I will have my virtual network in Azure. So it's as simple as that. So just go create the resource, create your network, define the subnet, and you have your network created. Here we go. So this is my network, Sakofi. So my network has the IP address space. Um, Currently, I don't have any devices or any resources connected, and I currently only have one subnet.
So if you have devices connected, is it going to be the NIC of those devices, or is it going to be the physical devices that will be
Oh, it's
sharing
going to be the network interface of them.
networking? Is there any limit to how much you can have on a specific resource or VM account or subscription?
On a specific VM.
I mean, on your account, is there any limit to resources like NIC that you can actually have?
Oh, okay. Yes, there is. So there is a limit. How many network interfaces can a virtual machine have in Azure? Depends on the size of the virtual machine that you've selected, right?
Okay,
Yeah, so that's sort of like when we get to compute, we'll cover that in more details. But the
okay,
number of network interfaces that a virtual machine can have in Azure depends on the virtual machine size that you selected. But one thing to also mention is that that's not a pattern that you see that's very popular, right? Many people are not deploying into the cloud with multiple network interfaces and all that stuff, right? Of course, those use cases still exist, but you don't hear as much about them.
all
when an organization is doing a more cloud native approach. So, okay. So that's it. So I've created a virtual network. So let me go to show you what I currently have in my Azure environment, and then we can move on. So what I've currently done is I've created a virtual network called UK South VNet with that IP address range. My virtual network has a subnet in it called web subnet. So that's what I've done. So the next thing that we're going to talk about is IP addresses for virtual networks. So that's the next thing that we're going to talk about. So let's go to talk about IP addresses in an Azure virtual network. So let's start first with private IP addressing. Every resource in a virtual network gets a dynamic IP address from its subnet range. What does that mean? Here's what that means. I just created a virtual network in UK South. My virtual network has a subnet in it. Now, this subnet has an IP address space of 10.1.0.0/24. Any device or any resource that I deploy into this subnet will automatically get an IP address from this range of the subnet. That's what that means,
Okay.
right? So every resource gets a dynamic IP address from its subnet range. So, however, we can convert that IP address, like what Kofi mentioned earlier, we can convert it from from dynamic to static. But here's a piece of warning for everyone. Whenever you want to convert your IP addresses from dynamic to static, do not make the mistake of doing it from within the virtual machine. Convert it to static from the Azure platform, not from within the virtual machine. Sakofi, do you know why? I want to guess why. Why is that important to say? If I have a virtual machine in Azure, you know that on Windows I can go to like the network manager, I can go to change an IP address to static and do all that stuff. But in Azure, it's not recommended to do that. If you want to do that in Azure, go to the Azure platform and change the IP address assignment of that virtual machine to static on the platform. What's the reason why you think
I
for
think
that?
with this one, I remember the first time I started messing around. So I came across that. I thought, oh, I've created a virtual machine. I need to assign an IP address. I mean, my what I know about networking is that I have to go on to the TCP/IP property, configure an IP address. And when I did that, it wasn't working. I bet you remember when
I
you,
remember correctly
yeah,
because that was a common. So that was when Sakofi and myself were working together at that point. That was a common thing that happened. People
yeah,
come to me and people are like, I can't get to my virtual machine anymore in Azure. What happened? I just changed the IP address to static. But you know what? It was working for a few minutes, right? It's going to work for some minutes, and then you lose connection, and then you can't get onto it anymore. So one thing to know is that when it comes to networking in the Azure platform, the cloud always wins. The
yeah,
cloud platform, you configure the networking
on the
in
cloud.
Azure from the cloud platform, not from within the resources themselves, except in like a few situations like firewalls and stuff. But for the most part, configure things from within the platform. So another reason for that is this. So Sakofi, so imagine this. Imagine I have this virtual machine that exists on this network over here. Now, this network is 10.1/0. I have another network over here in Azure, and this network is 10.2/0. I create a virtual machine over here. Now, this virtual machine, I've given it a static IP address of 10.1.0, and I've done this from the Azure platform. What happens if I move this virtual machine from here to here? I lose connection. However, if I made it static from the platform, if I move it over here, it's just going to get an IP address from the new network, and I can go change that to static. Does that make sense?
Yeah.
Yeah. So that's one of the things. So you do that from the platform. So let me show that to you very quickly. Right now, I have a virtual network. I'm going to go to my virtual network in Azure, and I'm going to go to deploy a virtual machine inside this network. So if I go over here, let's go to virtual machines. And if I go to add, and then after I've done the Sakofi, I think then we can take some more questions.
Sure.
So let me go to create my virtual machine. and I'll put it in the same resource group. I'll call this lab VM01 in UK South, Ubuntu system. I'll leave that size. Oh, that's too powerful. Microsoft trying to spend my money, Sir Coffee.
It's
why? Why are you going to give it 16 gigs of RAM, right? Yeah. At least be a little bit subtle, right? Don't don't do that. Okay, they've even yeah. You know what? I'm just gonna pick that and select that. That's fine. That's still too much, but I'll cope with that. Okay, let's do that. Let's give it a password, and let's give that a password. And once we've done that, I go to next to disk. I'll skip the disk. I'll go to networking. So under networking, I can go to put this in my network, which is automatically detected. I can put it in that subnet. And when I do this, and I go to say create this virtual machine, once this virtual machine is deployed, it's going to automatically get an IP address from the subnets that I've put it into. Okay, so we can take some questions, Sakofi, sorry.
all right. Let me just bring this up on the screen. So, yeah, the question uh, is if no multicast support with Azure SDN, then how hosting of servers or apps which runs on multicast will be getting handled over Azure?
Very good question, Vishal. You have to redesign it. So that's the way it is. So the way it works is there's no way around it. You've got to redesign it. So I'll tell you. So from a networking perspective, so a lot of network high availability scenarios use multicast, right? So like you have like your HSRP, your GLBP protocols, they all function using multicast. So I've worked with Sir Kofi also for a security company, and together we've worked together in a security company that produces firewalls, and the protocol that uses also multicast.
Multicast,
However, for Azure, that needs to be changed.
yeah,
So what many organizations will do is they will redesign their solution, all right, maybe to use something like HTTP to do communication with each other, and maybe they'll have sort of like a storage account where they can decouple the communication from the resource themselves. But essentially, Vishal, it has to be redesigned.
yeah.
So you can't use
I
multicast.
think even with Sophos, the XGHA relies on multicast, and moving it to the Azure in terms of doing a HA, they have to use a different way technology or rely on the resource that are available on the Azure platform to do the same tasks, I guess.
Exactly. Exactly. So here we go, Sakofi. So I have my virtual machine here. If I go under networking, you see that my virtual machine has an IP address from its subnet automatically.
Yeah,
If I wanted to convert that to static, I can go to convert that. I can go to the IP configuration. And if I go to that IP configuration there, I can switch this from dynamic to static. But I do this from the platform. I go ahead and click save. So now my virtual machine will still be DHCP. However, the Azure platform will always assign this IP address to that virtual machine.
nice.
Okay, so let's move on very quickly. So that is private IP address and that. So what about public IP address? How does that work? So let's see public IP address. How does that work? So here's the first thing. Public IP addresses can be assigned on demand. Is that a good thing, Sakofi? What do you think?
On demand. I mean, I guess from my point of view, if a resource do not need a public IP or that doesn't need to communicate outside, then it doesn't really need it. So being on demand, I guess that's the one probably good in my point of view.
What about if you're so Sakofi, you're responsible for security of your company?
Yeah,
Would you give every developer
a public IP. No,
no, not public IP address? We give them permission to be able to assign public IP.
no,
So that's the
that's
danger,
too risky. I mean,
right? But because that's the danger there is that public IP addresses has now become a commodity. Remember how tough it used to be? I remember then, I paid Sakofi, I paid like a lot of money to get my ISP to give me like a static public IP address. I can just go on Azure and get like about 4 or 5 within the next 3 minutes, right? And I have like a static public IP address just flying around everywhere. So public IP address can be assigned on demand. However, for security reasons, you may want to lock that down a bit in your organization. If you wanted to do that in your organization, I'll show you very, very quickly without spending too much time on it because we're talking about networking here. But how you can do that is we talked about role assignment last week. But if you go to under role assignments, the permission that you can use to control that, I'll show that to you very quickly. So access control, I'll go under my roles. And under my roles, I'll go ahead and let's make that a bit smaller. Yeah, that's better. And what I'm going to do is I'm going to just take one of the rows and I'm going to quickly clone this row. And I want to show you the permission that we can remove if we do not want people, or that we can exclude if we don't want people to be able to assign public IP addresses. So if I go to the role itself, so we covered all of this last week. For those that let's go check out the previous video. Let me look for the network resource provider. So get me the network resource provider. Where are we? So Microsoft Network resource. Here we go. So if I go for the network resource provider, under actions, if I go for Control F, search for public. So IP. You know what? Let's just go that application gateway, backend network connection. That's the thing, is that it's just so wide, right? There's just so many things that's going on over here. So, but if I scroll down to, oh, you know what? I think I have a better way. Here's a better way for me, David. So just search for it. That will make things easier. Just search for it. Public. There we go. So if you have a look, so join public IP address. So you can restrict or you can exclude that permission, right? Write public IP address, create or update public IP address. You can exclude those permissions if you wanted to do that. So anyways, that's just by the side because it's not the main topic that we are covering today. So public IP address can be assigned on demand. It can be IPv4 or IPv6 or both, from what you can see on the screenshot here. It can be dynamic or static public IP. So actually, when you want to buy public IP address from the Azure platform, you can buy individual public IP address or you can buy a range of public IP addresses. Yeah, you can go to Microsoft and say, give me a /28 public IP address range, and you can get that. That's powerful, Sarkofi, right? Very powerful. So dynamic IP, just be aware that if you have a public IP address that's configured to be dynamic, if you stop your virtual machine and deallocate it and you start it again, the IP address value may change. So just be aware of that. So that's the difference between static versus dynamic. Also, the SKU of the public IP address can be basic or standard. What does this mean? What does it mean by can be basic or standard? Right? So here is what it means, Kofi. In the very first study of this Azure Administrator series, we talked about something called availability zones, which are distinct data centers in the same region. So like UK South, we have 3 availability zones 1, 2, and 3, and they exist in the same region. So the region is UK South, and we have 3 distinct availability zones. So 1, 2, 3. If my workload is split across the 3 availability zones, in order for me to be able to use a single public IP address to be able to reach them, I will need a standard public IP address. In other words, a basic public IP is limited to one region. A standard public IP is limited to one zone. A standard public IP address can span multiple zones. So that's the difference. So basic, limited to one zone. Standard can span multiple zones. So, and that is what this is talking about. So basic means it's not zone redundant. Standard means it's zone redundant.
Got it.
Nice. So let's move on very quickly. So ideal timeout can be specified. Okay. So, and I mentioned earlier, I said you can purchase a contiguous address prefix. So for example, if I go to the Azure platform, I can go to purchase a public IP prefix. right? So I can go, hello, Microsoft, give me an IP address that's a slash 28. Should we buy slash 28, Sakofi? I don't think I have enough money in here.
Yeah,
But
right.
once you sell some of your gold in the gold in your gold farm, for those that don't know, Sakofi is a rich man, man. So once you sell some of your gold in like the gold farm, we got the money. So I can go buy a public IP address range and I can say I want a slash 28. That will be give me 16 public IP addresses, or any of this. Okay.
So the minimum you can actually get is two. There's no point
Yes.
buying.
Yeah, exactly. So but they'll be contiguous. Okay, so what I'll do right now is actually I've already done that. So we've talked about public, we've talked about virtual networks, subnets, software defined networking, we've talked about private IP, public IP. So let's quickly talk about a few more things and then we'll stop for today. So, few more things and then we'll stop for today. So, what about security, David? What about security? Because the concern is that I have this virtual machine that I just deployed into my network. This virtual machine has an IP address that's reachable on the internet. I can go to connect to it from the internet. David, I want more security than that. I want to be able to restrict what this IP address can communicate with. So, I want to be able to restrict that. How do we do that? So let's go to sort that out. So let's bring this up. So what I'll do is I'll go to SSH to that. Yes. And sorry. Okay, so that should connect me to my virtual. I messed up my password. Yeah, here we go. So connected to my password now, and then connected to my Linux VM. So what about security? What can I do to be able to Oh, okay. This is strange. Okay, let's go back. What can I do to be able to do some security around that? So one of the options that we have is something called network security group. So network security group, what it is this is a packet filter. So this is a very important point, Sir Kofi. Network security group is not a firewall. It is a packet filter. So Sakofi, I'll put you on the spot here a little bit, but you're an expert in this. It's nothing to you, right? So what's the difference between a packet filter and a proper firewall
Well,
to help our audience?
yeah, just to see if I can get this correct. So essentially, when you have a firewall, I mean, there are many things you can actually do, and also is most of them are very stateful. Once you open the traffic, will definitely allow traffic to flow the other way once there's a response, right? But with a packet filter, I believe that will just be more of I mean, it just the once the traffic comes in based on
Hmm.
a specific direction, it will only allow that. That's it.
Yeah. So actually, like in this particular case of network security group, it's also stateful. So
Okay.
it can also keep like the state. However, the first point that you make, that's the powerful point there, which is a firewall does many things. All this is doing is it's looking at the IP address and it's saying this IP can talk to that IP. What is going on in the communication that this IP is trying to do? Is it full of malware? Is it full of exploits? It has no idea. It cannot do deep packet inspection. All it can do is this IP can talk to that IP. The IP cannot talk to this IP. So that is basic packet filter. So a network security group is not a firewall. It does not look at your packet on a deeper level to check if there's anything malicious going on. So be aware of that. It's just a packet filter. All we can use it to do is to define security rules that we can use to specify allow or that we can use to allow or deny traffic. So that's all it's doing. So we can allow or deny traffic based on source IP. I can say the source IP can talk to that destination IP. So source IP, destination IP. I can say this source IP coming from this port can talk to that destination IP on that port. So source IP source port, destination port, and protocol. So these are called the 5 tuples. So we can allow or deny traffic based on these 5 tuples for network with network security group. So I'll just quickly configure that very quickly for the people inside Coffee. So if I go to here, I have my virtual machine. And if I go to, first of all, go create the network security group. So I'll just type in NSG and I'll click on network security groups there. And I can go to click on new. And once I have this, if I go ahead and do virtual network source group, so the name, I'll just call this my web subnet NSG. So I have my security group there. So let's go ahead and create it. So it's very easy to create. At the moment, I'm not defining any rule. I'm just creating it. So once it has finished creating it, which should just take a few seconds, then I can go to define my rule. And this is one of the rules that we're talking about earlier, Sakofi, that you mentioned. So if I go to under inbound rule, you notice that there's a default rule that says allow VNet inbound.
Oh, I see.
Any port, any protocol, anything from virtual network. So in other words, everything within that virtual network can talk to each other without any restriction if I apply this default security rule.
And there's one for load balancer as well.
Yes. So this one is to ensure and make sure you don't want to block this one if you're using load balancers, because the Azure load balancer needs to be able to check the health of your instances. So that's what this one is for.
Oh, okay.
Yeah. And then there's a final
So
deny.
once you create the rule, I mean, it's not automatically attached to anything. You do have to associate it with the network or specific NIC.
People don't have any idea how honored we are to be listening to Sarkofi. Right? Look at that was exactly the point, which is you've created it, but in order for it to actually start doing anything, we have to associate it to a subnet or to a network interface, like you said. So that's the way that it works. But one thing to quickly mention is if you look at this priority of the default ones, you notice that they're very, very high numbers.
That's
So
correct.
network security group operates similar to firewall. So it goes from top to bottom. So if I wanted to, I could go add additional rules. So the lower the priority number, the that means it's going to be assessed quicker, earlier than the others. So if I go to, and by the way, I believe that we can go up to the priority number over here. I believe that we can go up to priority number is a 4,500. Yeah, so that's it. So between 100 and 4096 is what we can use. Yeah. So I'll just start first with priority, 500. And I'll say block SSH is the name. So the source, I'll say, I can say any, I can define specific IP addresses. I can use something called service tag. So what a service tag is, it's a list of IP addresses managed by Microsoft. Because as you can imagine, Sakofi, there are many services in Azure. So let's say I want to allow anything that's coming from the API management service in Azure to talk to instances in my virtual network, right? That's something that if I have to be manually updating the IP addresses myself, that's painful for me to keep up to date. So Microsoft maintains the list. I just define the service tag to say anything that's API management, or I can even go a bit further to go on a regional level. Anything Azure storage dot this, allow or block.
That's interesting. So that means on the regional level, you can block every storage, but allow it for only specific region.
Exactly. So if you only have storage in one region, you can block everything else and say, I'm only allowing outbound. If I'm going to add an outbound rule, I can say I'm only allowing outbound to storage in Australia, Southeast and stuff. So for now, I'll just say anything that's coming from the internet with any ports. If the destination is my virtual network or any of that, the destination port range 22 or SSH, right? And protocol TCP, I want to deny that. And I'll say block SSH and I'll click add. So I've added this. So this is going to be evaluated earlier than these other ones. So I've added that. But to Sarkoph's point, I've not applied it, so nothing is actually going on. So if I want to apply it, I can go associate it with a subnet or a network interface. I'll just go to associate with my subnet. So if I go to subnet and I go to associate, and I can go to select my virtual network, select my web subnet, and click OK. And that's going to associate that.
Okay, so hang on. So what about if I associate NXG to a subnet and a different NSG to a NIC and a
Hmm.
DNS? What happens?
That's a very, very good question, Sir Kofi. So here's what happens with that. So let me bring up Paint, and let's use that for what we're talking about here. So here is what happens with that. Actually, you know what? I'll just go to use this to define that rather than using Paint. So let's erase that. So I have a subnet, and on this subnet level, there is NSG over here, NSG. And I have a virtual machine in this subnet, and on this virtual machine's network interface, there is another NSG here. So what happens? Both of them will apply. So here's how it works. If traffic is originating from my virtual machine going outside, it's going to first of all go through this NSG.
Okay,
If it allows it, it's going to go through. Then it's going to go to the subnet NSG. If it allows it, it's going to go through. So essentially, to allow traffic, both NSGs must allow the traffic. If one of them blocks, they go to get both get blocked, even if you allow it on the other level.
okay. So it's more like different level of security.
Exactly, of application. Yeah. So if traffic is coming from outside, coming inside, the first NSG that will be checked is this one.
Yeah,
If this allows it, then it's going to be checked by this one. If this allows it, then it's going to go to my virtual machine. If any of them blocks it, then it gets blocked.
correct.
Yeah. So that's sort of like how that works. And by the way, here's a very good troubleshooting tool. And we're moving close to the end. I'll just talk about DNS, and that's it for today. We'll continue tomorrow with intersite connectivity. So for this one, here's a very nice way to do short troubleshooting, Sarkophy. So first of all, I've associated this to my subnet. So let me go to my virtual machine. So here's a very nice way to troubleshoot NSG if you have multiple of them. So go under networking, go under the network interface that you're working with. And under the network interface, scroll down and look for effective security rules. So it's going to let you know what's the effective security rule that's cumulative for this virtual network interface. So it's a good way to do troubleshooting. So it's going to let you know what's on the subnet level. So for example, it's brought up to me and says, hey, this is on the network interface level, but it's letting me know what's allowed, what's not allowed from the a cumulative effect. So let me quickly just test this out, Sarkophy. So because earlier I was able to connect via SSH and I'm still connected. So that's one other thing to say. Because I have an existing flow, it didn't kick me out, right? I'm still connected to that virtual machine via SSH. However, if I exit and I try to connect again, now it's not allowing me. So just be aware that if someone has an existing session open, except that TCP session times out, that flow will still carry on. So be aware of that. So, Sarkophy, let's end this session with DNS because Sarkophy asked me some interesting questions about DNS earlier. So, here's the thing about DNS, and I'll make this very quick, but you'll enjoy it. So, this slide, I designed this slide, Sarkophy. So, it's
We
very
got
interesting
a
one.
question here. Can we answer that one real
Oh,
quick?
yes, please. Let's do that.
So, right. So we got Steven here. So he say, if I create a virtual machine and delete it immediately, will I still get charged because I have subscription like pay as you go?
Yes, you get charged for so you're going to get charged on a per minute basis, I think. Actually, yeah, I think you're going to get charged on a per minute basis. So you're going to be charged for that for the minutes that you have it running. So 1 minute, I believe it's on a per minute billing basis. Yep. So Azure Virtual Machine is a per minute billing. So I'll bring that information up on the screen for you, Opayemi. So let me go over here. So if I go minutes, yeah, so it's per minute billing that we have. So you're going to get charged for 1 minute. But if you're currently on the other one, that'll be fine. Okay, let's quickly bring this to a close. So what about DNS? How does it work? So DNS option in Azure, there are three options that we have. So the first option is Azure provided name resolution. What does that mean? David, help me to understand. So this is the default option, Azure provided name resolution. So here we have no problems, Okoyevi. So here we have a virtual network with two virtual machines, web virtual machine, data virtual machine. By default, without me deploying any DNS, Azure has an Azure provided DNS that's doing DNS resolution. This virtual machine will be able to resolve the name of this virtual machine using Azure provided DNS. See, how does that work, David? Let me show you that to you very quickly. I have in this environment, I have two virtual machines on the same subnet, WebVM01 and WebVM02. If I do ns lookup WebVM02, I can resolve it, right? I didn't have to set up any DNS, right? So it automatically resolved that name, right? So, and I can even do a reverse lookup. I can do ns lookup 10.0.0.5, and it's going to find it and say that's that VM over there. How does that work? The reason for that is this, Kofi. So I'm looking at the time here. We'll round up. So here's the reason for that. The reason for that is if I go to my virtual network that I created just now. So let's go to my virtual network and let's go see why that works by default. Anything that makes it work. Let's go see my virtual network over there. And let's go to on the DNS servers. You see that by default, it's using Azure provided DNS. So that is what makes that to work. So let's go back to the slide. So the Azure provided DNS by default provides resolution of public DNS name. So if Web01 wants to resolve google.com, the Azure provided DNS will resolve it for it. It provides internal DNS name resolution. If Web01 wants to resolve the name for data01, Azure provided DNS will resolve it for it. It supports the reverse DNS lookup like what I just did, right? I just went to look up the IP address and it's going to give me the name. But the downside is I have no control of the DNS zone. I cannot log into this Azure provided DNS and add a record, delete a record, or do all that stuff. So all that is automatic. I cannot even get to it, but it exists, right? So no control of the DNS zone. So the Azure created DNS suffix cannot be modified. So by default, you're going to see like this random DNS suffix. I'm not sure if you noticed that earlier, Sakofi. Look at this. When I did the resolution for this earlier, look at that DNS suffix. Isn't that interesting? Do you want to remember that and go WebVM02 OLMGA FWAP Quang right? So essentially,
It's needed because it have to be unique. You need
yeah,
to by the
exactly. So that's the reason why it's random. So essentially, it's not the best, but you get something for free, so it works. The second option is customer managed DNS server. What that means is I can go to deploy my own virtual machine, put DNS on that virtual machine, and then use it for my name resolution, right? So the way that that's going to work is it can provide internal name resolution. So I can register my DNS records to it, and I can resolve internal names. I can configure forwarding to point to the Azure provided DNS, which is this one, right? So that's the Azure provided DNS. I can say, hey, my DNS server, if you are not sure how to resolve anything, go to the Azure provided DNS server. But this is where we'll stop today because this is an interesting thing. This is a mysterious IP address, Sakofi. That IP address is the same for every Azure virtual network in the world. 168.63.129.16. We'll pause there. What is this special IP address? It has a lot of use cases in an Azure VNet. If you Google that IP address, is going to come up in a lot of Microsoft documentation, probably in about 6 Microsoft documentation, that IP address. So let me go to quickly Google that. So let's go to 168.63.129.16. 129.16. So I'll copy that. I'll just go to google.com and I'll just search for that IP address or coffee. And this is where I'll stop. So what is this IP address? So we'll stop there for today. We'll pick it up from here tomorrow. What is this IP address? Thanks very much, ladies and gentlemen, for joining us. Sir Kofi, as always a pleasure to spend some time with you walking through technology together.
So I think we got a question, and after the question, then we also have a lab that we can you can actually go through as well.
Good point.
So the question is, what is the default TCP session timeout, and is it configurable from any settings over the GUI? This question is with a reference to existing SSH remain connected explanation.
That's a good question. So the answer to that is yes, it is possible. It is configurable. So in on but on many levels. So I won't be going to I won't be able to answer like the full details, but the answer to that is yes. So for example, I can configure that on a load balancer level. If I'm using load balancer as my ingress point, I can configure that from a public IP level. So for example, my virtual machine is using that public IP address. If I go to that public IP address, I can configure the TCP session timeout. So you can see the idle timeout. So the lowest I can go is 4 minutes. So, but that's the lowest. So if it doesn't receive any flow, any traffic for that flow within 4 minutes, it's going to time out. But the answer to that is yes, we can do it at different level depending on how we've configured our ingress from the IP address, from the load balancer level, and other levels also. Hopefully that makes sense to you, Vishal. Yeah. Okay, so Sakofi, apologies everyone for going too late. So Sakofi, I'm so sorry about that also.
No worries.
So
It's been wonderful time. I mean, looking into this. So
yeah,
all we can do is thank you. So we got a lab that you can also follow. We will actually publish the lab after this session. So for this, so essentially, we already mentioned that we are using the Azure, Microsoft 10104 exams, sort of like a lab manual.
yeah,
So with this lab, what we're going to do is, right, you're going to create and configure virtual networking. That will be the first task. So essentially, yeah, David, if you click on the next, right, so you deploy the resource and a VNet just like David did, and in there you create the subnet 1 and subnet 2, assign IP address to it, and then to the next. So you assign an IP address just like David actually demoed in this session as well. And then with a task number 3, you just have to create public IP address and private, like I said. Yep. Okay, move on. Right. So for task 4, we'll create the network security group. So just like David demoed, you have a test whereby you have an RDP and then we block because there will be no associated NSG. And then once you define an NSG, it will allow the RDP to connect successfully. Right. So, yeah. And then the fifth one is configuring the DNS, the internal DNS resolution, just like David demonstrated. And the last part will be public DNS resolution. So I do encourage you to go through these labs, because after you've gone through the lab, you're definitely going to get the message home. And so I do really encourage that you go through the labs. So yeah, David, thank you for this session. Definitely been wonderful, like all the other sessions. And I mean, we're looking forward to tomorrow. So tomorrow too, we have another session. Hope you guys will join us, and we will keep this Azure Studies series going
awesome.
strong. All right.
Yeah. Thanks very much again, Sakofi. I appreciate it. Thanks very
Thank
much,
you.
everyone, for joining. Yep.
All right.
See you. Bye bye for now.